Hello, this is Matthias. I was a bit late, or very late, to put out the link on the meetup. Thus, we will be waiting a few more minutes to get started in case anyone is looking there for the link and not just going to the home on YouTube. At this point, I'm not seeing really anyone having tuned in, so there's no point in really starting. If you have tuned in, drop a message in the comment box so I see that, but at this point it looks like no one has found the stream yet. Have you wondered why you would need JavaScript in SQL Developer? After all, you got SQL, you got SQL, and that's all you ever would need, right? Well, maybe, and maybe not. Hello, this is Matthias. This is the monthly, or somewhat monthly, meetup for SWEOUG. And let's see where we... well, let me stay here. We were a little bit late starting this, and that was due to the link not having been broadcasted in enough time. It was my fault, I should have done that, but that happens. So we will get started with a presentation and talk a bit about this. I should say before we start, though, need to do that. No. Sorry, fiddling around here. Anyway, the presentation will be kind of introductory, talk about the different things you can do and how you can put pieces together, and talk about a bit inspiration for things you could do that you cannot do otherwise, just to set the expectations right for the presentation. So this is the SQL scripting presentation at SWEOUG. My name is Mattias Magnusson, and I run Evil Ape. And let's do this. I'm the owner and the consultant at Evil Ape. I'm the founder and the leader of the Swedish Oracle user group. This is where you're at right now. If you want to find me, you can find me at my blog and on Twitter, of course. I'm an Oracle Ace. And talking about the Oracle Ace program, let's talk a bit about it. We're a few that's a part of it, and we'd like company. So here's how the program looks. It has an Ace Associate level, it has an Oracle Ace level, and it has an Oracle Ace Director level. That's kind of the natural progression through the program as you grow up in it, as you publish more information, as you talk more and more, and as your frequency of publishing increases. That's the levels in it. So you start as an associate and you become an ace, and then eventually you might become an ace director if you're really active and good at it. So if you want to be part of it, contact me or some other ace you know, or communicate directly with the program. And I want to talk a little bit about the Aura World magazine. It is a very good magazine. It has content from some of the biggest names out there and some not so big names. It is also not published by Oracle or any commercial entity. It is by the user groups of Europe. I think everyone should read it. It has a lot of good features. Here's a little overlook of some of things that has been highlighted in the past. Recently there was a long thread of SQLcl material on how to do it better by Steven. But I should also say that it's not only technical, it has a mixture, and you kind of see that on these pictures. It has a mixture of content that I think is nice. It's not just for the techies, and it's not just for the non-techies. It's for everyone. So, what are we going to use today? Well, it's not much actually. It is it's on the Oracle Cloud, and we're going to use SQLcl. The version I've used when I did put this together was 20.2. This is going to work on just about any somewhat recent version on SQLcl. And the examples have been run against autonomous transaction processing database, the premier Oracle Cloud database. But this is not a cloud presentation. You can use SQLcl in the cloud. It's very easy to start using it in there, or you can use it on your machine going against the cloud. Just put up a wallet and you're set to go. It's very easy. But you could use it on your local machine to your local database, or in your enterprise to the database you have there. There's nothing in this that are only cloud. It's also cloud. So SQLcl then, in case someone that doesn't know what it is, it's a text-based interface for the Oracle database. It's based on SQL Developer. It essentially runs the same code. It's free, and it's built by the same team that builds SQL Developer. ATP then, well, it stands for Autonomous Transaction Processing. It's kind of strange name, or maybe not so strange, but it's not so declarative either. It's an Oracle database, automated with some machine learning. And yeah, well, that's enough, I guess. Where to start? When to start with these things? Well, Chris Rice is the man. He pretty much invented all the kinds of different tools that we use on a daily basis in the Oracle space. He put together mostly a bunch of information or examples and things for the SQLcl scripting features when they arrived some 4 years ago. And it's good, it's been there for a while. What's unfortunate is that it's a little bit stale, and I think it's stale because they would need input, someone to tell them what else is needed, or what would we need out there. My view is that it shows some complete examples of things that you can do. If you want this, then you can do it this way. If you want that, you can do it this way. It's not a progression through examples of increasing complexity like you would get in a textbook. It's a choice. I would prefer to be able to see the snippets of when I want to do a certain thing in JavaScript rather than just a piece of a puzzle. But other people probably prefer it this way. SQLcl, now we're getting into the scripting. And SQLcl is an object in there, and it pretty much is the SQLcl engine itself. So here in the example, script says that here comes a script. This is, you can type it directly on the command line in it. You can also put it in a file, but it works for small things. It works to just type it in like this to test things out. So here we say SQLcl dot set statement. So we're declaring or establishing the statement that we want to be able to run. And the next statement just says that let's run the statement that we have. This, of course, I should not say of course, this executes select star from dual. The output we see here is exactly what we would expect to see in SQLcl. So running with SQLcl this way means that it gets executed in that environment, and it ends up as normal output for you, and you get the normal SQLcl formatting and all of those features. That's sometimes very nice to be able to build up some SQL and do it that way. And I think the next slide will talk a little bit more about that. Yeah, so where would I do that? I could just have typed in that SQL statement and it would have done the same thing. This is true, but the idea here is not that you would just do static SQL like that. It would be a very long way to just write SQL. What you can use it for is to wrap it in logic, build your SQL statements, and get them to execute, and you can execute more than one, you can execute a whole bunch of them, and you can, of course, with logic decide that based on something I want to run a certain SQL, and other times you want to run another SQL based on input or based on something else you read from the database, you see, based on that you run a SQL and gets the output, but the first SQL you don't get the output for because that is just done in the background. So, and we haven't stepped far into this, but even this isn't possible with PL/SQL. You cannot from PL/SQL get SQL to be executed that ends up being formatted by SQLcl. You could of course have PL/SQL generate SQL for you that you would then run on your client, but can't do it for you. And let's stop there and talk about one thing, and that is any questions or comments that you want me to address. I'm not sure when I get to address them, if I see them immediately, but it may just be at the end of the presentation. But please drop them in there if you want to ask them, or if you want to comment on something. Otherwise, when we get to the end of the presentation, when there are no questions left, or if there have not been any, I'll just wrap up the presentation, just so you don't get caught off guard with that it wraps up pretty quickly. Okay, so let's look at reading arguments. Works just like any C-like language, right? But the very first line is one we can look at. It's context ctx.write. The context object has a whole bunch of functions. This is pretty much the only one anyone ever uses. Of course, there's people that does all kinds of crazy things, but this is by far the most used. There is also a print statement in JavaScript, but it does not interact the proper way with SQLcl. The output from it is easily overwritten when you move around with arrow keys to get an old SQL statement up. Then you see maybe 5 lines of text for that query that you ran before, and when you go down and don't have it there anymore, it has been lost. It didn't know that was what was there, so it was replaced with what was there instead, or before you printed that. So you'll want to use context for your output. It works pretty much like DBMS output. Not exactly, and we'll get into some of that, but it writes it and you see it when the execution stops, pretty much like DBMS output, where it is shown to you when your execution is stopped. Here you can flush it. There's a command. I think it's context flush or out flush, I think. So that's one feature that can be nice for that, I guess. Right, so back to the arguments that we want to read in. Here we have a for loop. It loops over the arguments that was passed in, and it just prints them out. And after it, we see an execution of it. I just ran it, entered a few arguments on the line. It prints it. The very first line is not an argument. It is the name of the script. This is shell style arguments, where the 0, the first argument, is the script itself. or the link, whatever, however you invoked it, the name of that. So then let's move on to the util object, and there are 4 or 5 different functions in it that you will want to use. On these slides in blue is what Oracle states about it. It executes whatever is passed in with a Boolean return for success failure. But it runs SQL, so what is this for? Well, it's not for select, of course, because a select doesn't really fail. It may not return data, but that's not a failure. How I think it's mostly used is for running DDL and know if it works. If you create a table, you know if that table was successfully created or not. And if we assume that we want to insert a row into a table that has a primary key, if the key already exists, it will of course fail, and then this will return false. So here's the example then. Binds is the bind variables. It's just an empty collection of bind variables. We don't need any for this, since everything is hard-coded. And then there is an util execute where we use this. We do an insert into the table, and we have a hard-coded value of ABC. The if statement here says that if it didn't work as intended, it will write out insert failed, and if it did work, then we just have the output inserted. Oops, that's not it. Oh, let's stay here. I didn't put out the output in a slide because this was pretty obvious. First time we will get inserted, and second time we run this, we will get insert failed, because now the key is there and the primary key protects duplicates from going into the table. So that's how that function can be used. Now on to the ones that are more, I'll put them, yeah, the ones that are mostly meant for select, I would say, because it's about returning data. So executes and returns the first row, first column. Wasn't completely obvious to me how you'd use that, having a big old result set and just pull off one column of one row didn't make sense. But it's a easy way to handle returning a single value, like a count of something, or an average, or that kind of stuff. Of course not without a group by, because if you have a group by, you will want to have more than one row, and then this is not the proper function for you to use. So in this case, we just want to print the number of tables in the schema we're in. There is not more than one row, just print the exact number of tables we have in our schema. Similar setup as before. We have a variable that takes the output from this command, and the command does a select count from user tables to check how many tables we have, and then we have a print or a context write to display it, and the output is below there. It's the number of tables is of course 42. It would always be in a proper schema. Then we have execute return list of list. execution returns an array rows of arrays row. That becomes a bit too technical wording for me to really understand. It took me a while to understand what this did and what was the difference between the next version of this that we'll look at recently that has a similar explanation. What it does is that it gives the result of a select as an array. That's a typo there, but it has an array. The array has rows and columns, so even the columns is an array. So let's take a look at how that would be. The array has indices for both the rows and for the column names. And in index 0, it puts in the column names for that column. So in the array, in the 0 level, we're only going to find column names, no data. So the column name of the first column comes in 0, the second column comes in index 1, and so on. Then on index 1, we're going to find our first actual data value, and that is for the first row. So there we get the row, the data that for that column that was in 0, 0, and so forth. So if we look at a little demo of how this works, so here we expand a little bit on the bind concept, in that I declare a variable to be used in the bind array. So here we have an array coming out of the call to this function, and in the select used pulls out the table name and the average row length from the used tables for tables, like the variable declared above. And after the SQL statement, we have the comma binds. We've had it in that array, and it then uses it. So the TB I declare there is the current TB in my SQL. And then when it has returned, it's a simple little for loop that steps through each row in the array, and it prints the first and second column. So it's going to print all the tables that were qualified. It's going to print the table name, and it's going to print the average row length. We have an example of this right here. It prints them, and since we started from 0, we're going to get the column name first, and then we're going to get the 2 rows that was qualified in this case. So because if we look at what we said here, on 0 index, we're going to get the column names, right? And if you look at the code, the for loop here starts from index 0. So we're going to start with the column names, and that is why we get the table name and average row length to be printed before we get the table names and the average row lengths of the actual tables in the schema. So that was one way to make a select, and for all of these util things, notice that it doesn't come out as output. SQLcl doesn't print the output of the sequence you're executing. You get them back into code constructs where you can use this data to do whatever you like with it. Print it out like we do in this example, or do some other funky business with. So here we have the last one was execute return list of list. This is just execute return list. And here the explanation is execute and returns an array rows of objects row. Again, doesn't speak to me really to understand what is meant with that. But what it does is that it grabs a select as an array of rows. So now we into, well, but how is this different from the last one? That was what that did too. Well, this array does not have an array of columns. It has named columns. So, like we see in the example here, on the array on index 0, there is a dot table name because we had table name as one of the columns we were selecting. So we get that back, and we can just pull it out by naming the table name or the column alias that we used. And of course it contains the value of the table name. So here we have a demo, prints the number of tables in the schema. It is identical to the last one, just we're using a different function, so we will see the difference in the code for how this is handled. The start setup is the same. The SQL is also identical. The only time we see a difference in this case is when we're in the for loop, which is also the actual logic to start the for loop with the parentheses and the initialization of I and so forth, which happens to be a big I there for some reason. Well, I'm not sure why. And anyway, that is also the same. It's just in the contract right that we see the difference. And here we see, instead of saying array index I, and then after that we have another brackets with 0 and 1 in for these two things. Here we have them as names. I much prefer this syntax, but if in case you have some generic code that doesn't know what it's going to get back, maybe the other one is better. And here's the output we get. The output is the same. What we're missing is the column names. So if we want to be able to print that, well, we're back to that the other one is maybe better for us then. And here's another one, the function get lost exception. Sometimes you either just want to check if everything worked fine with your call, or you want to know exactly what the problem was. When you call this, it clears the exception. So you cannot call it twice and hope to get the same thing again. So you can't do what I tried to do the first time I used it. I tried to set an if statement that said if get lost exception. Then I wanted to handle that exception. That doesn't work too well because it figures out the first call in your if statement understands that yes, there was an exception, something went wrong. So you get inside your if statement or in the true condition. And then when you print it, you get nothing because the checking of it in the if statement cleared it. It's not a big problem. You just set it to some variable and then you can use the variable, but it's one thing to be aware of. And so we've come in from previously used SQL and SQL and gone into JavaScript. Oh, that's good. But what do we do when JavaScript is not enough? No, when we want to do something that JavaScript does not lend itself to at all, or make it very, very hard. JavaScript was invented to be in your web browser. As a result, it doesn't function in a world where it should read files from your system. So that becomes complicated, or I didn't find a proper way for it. Fortunately, since this lives in a Java world, meaning inside SQLcl, we have access to that, and in fact we've already used it. All these objects that I've talked about with util and SQLcl and context and all of these things, they're essentially, or not essentially, they are Java objects that we have access to, that have been exposed so that we can access them. We just happen to often do it through pure JavaScript. And there are also cases where Java has a complete API to achieve something where it's not in JavaScript. You could possibly pull in some framework or something else to have it in JavaScript, but if it's already in the Java you've loaded, why not just use it? And here we have some things that you really cannot do, not in SQL and not in JavaScript, at least not all of it together. Like if you want to run things in a separate thread, and especially if you want in that thread to declare a second database connection or session, like so you want to have the session that you logged onto when you started SQLcl, and then you run this command that you've written with JavaScript, and in that you want to have a login to the database, and you want to be able to have these two functions side by side. That is pretty natural, pretty easy with Java, and it has boilerplate code. It's not hard to find. So in this example, what I ended up with, to make it somewhat brief, is to read a SQL from a file and execute it. So, and here we see in the beginning is a little bit of a pretty nice feature, I think. Instead of down in the code reference this long java.type and then tell where it's at in the whole structure of Java objects, we can declare a variable that references it, so that we can then later just say string when we want to reference it. So then we declare a variable for our statement, and it's a call of a combination of things here. We want to string out, we use a files object in Java to read everything in it. We get the file or the file path for the variable that's passed in, so we pass in an argument with ~1, like we usually do in SQLcl or SQL+. And we trim the line so that we don't get extra space and junk. And then we just do what we did in the very first example. We set the statement to a SQL statement and we execute it. Okay, so yes, that's where we're at. So here's the SQL statement that I've put into a file. So I'm just showing it here just to so that is obvious what I'm doing, and I'm using a top n query here, as the last line in the SQL shows, just to limit the number of rows that we'll be looking at. Then I invoke it like we used to invoke SQL files. In this case, it's a JavaScript file, so it's an at the name of the file, and then we pad on the parameter. In this case, it's a file name, user object SQL, and it runs the SQL, and I get the output. Because I use the SQLcl set statement and run, that's why I see it formatted for me in SQLcl. Very nice, but I could just have done at on the file name and gotten it out. Well, yeah, I could have, but let's see if I get into that. No, that's the use case, so let's jump back. I could have done that. The point of this example is not to show something new, it's to show things that can be done. Of course, we would like to do something more here than just to run a SQL, otherwise we've not achieved anything other than adding a bunch of complexity to a very straightforward operation. Let me take a look here. No questions, no comments. So, okay, so with that, I've pretty much gone through the basics of the components, what we can use, and the building blocks of putting together things. Of course, we would put in much more logic and stuff into our JavaScript, but that is the main things needed to be able to create objects, read data, update data, and so forth. So now we're moving into, I don't know, inspirational. I'm going to talk through 4, I think it is, use cases where I see that examples of how this can be done where you couldn't do it another way, and it gives you new possibilities in SQLcl, and of course none of this can be done in SQL+. I guess that's pretty much obvious because it's a whole different set of code structure. So in this case, I don't know if everyone works with multi-tenant today. I think more and more people would. It's even without license, you have access to 3 PDBs today, and if nothing else, you ought to have it in your own environment to play with. It's a very good technology. Anyway, what we are looking here is the statement alter session set container equals and a value. It is how you move around, how you go into a pluggable database, how you move up to the CDB, the root level. If you work with this for a while, especially in environments with many of them, that command becomes part of your muscle memory. And I don't know, if you're like me, you may get tired of typing it over and over. So what's the point then? Why couldn't we just write a PL/SQL procedure like we've always done with these things to run that command? It's just a pretty basic execute immediate command, right? Well, you start playing with it and it kind of works. Problem comes when you try to go to the root container. You get into other problems too with this, but you cannot use it to go to the root container, and the reason you can't do that is that you're not in one PL/SQL block allowed to switch to the root container, and sometimes not even between other pluggable databases. And the reason is that when a PL/SQL block is compiled, a whole bunch of security is checked, and your context and all of the world you're supposed to be in is in the PDB you're in. So you're not allowed to switch to the root PDB, because then in theory you could do things that you were not allowed to do from the beginning and so forth. So it just doesn't work. And there's really no way around it. You have to be in SQLcl, anonymous block or a stored procedure or something to run and execute immediate. And that's really the only way to handle it. There's maybe some roundabout ways, but pretty much that way. From JavaScript, you get a whole different situation because every call is separate. So you can run an alter session and have it change the session, and then the client gets control back, like after select, and it can issue another command and keep going in the session that just shifted containers. That's one. So let's have a little bit of story time here. So I recently had a big problem in a situation where we were running some fairly big, complex, performance-oriented tests, and sometimes it didn't work. It wasn't just that it was a little bit slower; it was horrendously slow, and sometimes it was due to the database was being overloaded by something else, and that's fine. You're used to that. But sometimes it was someone did something else on the database server, and well, yeah, as a DBA you can kind of control that. You can log on and check that. But sometimes we could not, for the life of us, figure out why it was slow. Was it the router? Was it the network? Was it something with the application servers? Was it something around the application servers? Was it possibly the network over closer to the application servers on the virtual level, which the application servers are in a virtual space? We had firewalls, and we had load balancers, and we had all kinds of things. We didn't really know, and it happened time after time that we ran a test. It ran for quite some time, and then either when we were in the middle of it or after, we noticed that, well, this was a failed effort. And sometimes it's not that big of a deal, but here we're collecting a whole bunch of very senior people to do a test and reserving them for the test, and it was, well, useless. And of course a lot of people wanted us to be able to validate ahead of time that it was going to work. And we tested many different things with running SQLs in different ways, and running a SQL block that did a whole bunch of selects against dual and other tables to see that if we get a certain number, we would be in good shape. It didn't work because, and of course it wouldn't, because it wasn't always due to the database. And that part is very hard to check from the database if it's not part of the database. And after testing a bunch of different things, I came up with a solution where from the client, this being SQLcl, executing as many select star from dual as I can in a time space. We ended up with a minute, but it could probably be just 10 seconds. It would give us the same data, I guess. And we get a whole bunch, a very large number in a minute. But this very simple test has by far been the most exact prediction or predictable way to make it predictable how something will work. It never fails. We can use that number pretty much to estimate how well a test will go. So it has been a very big success factor. So how was it done, and how was it different from from a normal SQL, PL/SQL or SQL file. It logs on, gets its connection, then we run this file that sets a timer and start firing off and doing thousands of round trips, select star from dual. So every time we do a select star from dual, we navigate over the network to the database, get into the database, run the query, and we get back out again. Lightning fast, but it's every time it's a round trip. So this navigates the network, the load balancers, the firewalls, everything. And with that, a single file that did that, and it stored the result in the database, so we could massage it with SQL. We could take that, we could wrap up SQLcl and this file. We could give it to the app server people that are deploying things. They could send it off to any server in the enterprise they wanted to, and from there we could validate how well this worked. So that becomes a standalone utility, could just be shipped out and could be executed from someone that doesn't even know SQLcl, wouldn't even need to know that SQLcl exists. They just ran a script and it did this, and we stored the data in the database, and we could predict how well it would work from that machine or how well that machine behaved. This of course could not be done with a SQL file. We could have a SQL file that had very many select star from dual, but that doesn't allow us to run just as many as we can do in a certain time space. It wouldn't really allow us to store the result in a table because it's not PL/SQL at that point. And every statement would have to be parsed. It couldn't be done as fast because the whole file management threw off the whole behavior. So that's one part. Couldn't we have done it in PL/SQL then? Well, the code could be ported to PL/SQL, but it cannot get the job done. The reason it cannot get the job done is that you have your PL/SQL block. Once you fire it off, it gets into the database and it does its work. And that's fantastic because it's lightning fast. It's many times faster than what I'm doing here with navigating back and forth. So from a performance standpoint, that's of course how you would want to do it, but not for validating how well the round trips and the whole mechanic around that worked. So that didn't work, but with JavaScript and SQLcl, it was possible to build this nice little tool that I probably wouldn't have gotten otherwise, because having trying to explain to a Java developer to get exactly what I wanted and not anything else, and not an optimization that we wanted to put in because it's better to do it this or that way. I could control the whole scenario from this. So now let's talk about somewhat completely different way of doing this, and I haven't shown examples because it's quite a bit of code to show and doesn't work better in a workshop than it really does in a stream. But let's talk about wanting a new command. The things that the SQLcl team gave us, it includes things that allows us to create a feature that we may think should be part of SQLcl, but it's not there. So in this example, we have a command. We want to say S my schema. When that command is executed, we want the tool to in that case do alteration set current schema equals my schema. And the way we do it is that we add the command by extending the command listener in SQLcl. That sounds complex and hard, but it's really not. There's lots of places where you find the boilerplate code for this. There are a couple of 3 places you change things, and the rest is just boilerplate. It's you just cut and paste and just use it, because most of it is essentially saying that we want to add a command, we want to have this name, we want to run these things when it's executed, and that's what the rest of this boilerplate does. So you just plug in the code for what it's supposed to do when that command is being executed. Like this is the place I talked about before, right in the beginning of the presentation, where Oracle or SWEOUG has put out many different examples for different things. There are examples for how you make SQLcl laugh at you when you get a failure with a command you write, and it does something else when the command succeeds, and all kinds of things. This case, this exactly scenario that I'm talking about here is one of the examples that you can just take and plug in your environment, and now you have a new command that you're able to use. And the 4th use case then. It becomes a little bit more complex, but I think here we really start to see features that cannot be done in another way. I just noticed that my picture seems to be frozen, but well. In this example, we want to read a SQL from a file. We want to create another thread or connection. Let's see if that works. No, it doesn't. So we want to read it. We want to create another connection in which we execute this. And then we want to, in the first connection, be able to pull the wait events every so often and print out the parts from it that we find interesting. We want to optionally create a SQL trace file through that run and pull it down afterwards and have it on the machine. I find this extremely useful to do. Could you do it some other way? Well, kind of. You could have one session in SQL Developer where you run the query, and you could have another one that every so often reads the data and prints it. Well, you would only see the data after you're completely done, of course, but that's fine. So you could do it, but you couldn't do it in one command that does it all for you and put it all together and these things. So you couldn't get it as nice and neat, and you couldn't write something that you just gave to someone else and said, you can use this, it does it for you, and if you want help with looking at the SQL trace, come back and talk to me, because you would have to teach them a whole bunch of different commands to actually do these things. So then it's not the utility, it's not a command, it's more like teaching a skill set. And that's it. I think that's enough of use cases to show a little bit what could be done. We could at some workshop or presentation talk more about that. If there's an interest, then just let me know, and we'll try to schedule that for the future. So let's talk about the summary of what it is we have here. With JavaScript and Java, it allows for features that SQL and SQL Plus or PL/SQL cannot do. We can extend SQLcl to have any command that we think is missing in the tool. We can use this as our environment where we can prove how to do things for Java developers. We can of course do parsing of SQL. We can do bind variables. We can prove how to do it with pure JDBC without using Hibernate. Anything we want to show someone that where they say, well, it's not possible or it's too hard or something. This is a good environment to show how it works, how it can be done. We can simulate the behavior a Java application would have so that we can inspect it ourselves and we don't need help engineering that, as long as we can understand the behavior we want to simulate. We can of course use it to fine-tune SQLcl to fit our personal workflow. Very often we don't work the same exact way, all of us. We have certain things we do a lot of time, and we want data to be presented in a certain way for us, and we have a whole bunch of different SQL and other things for it. Well, we can wrap it up in a bunch of commands and tools and have easy access to it. And I think it's a very nice tool for all your automation needs. We have, with this, we have one platform where we have SQL, PL/SQL, we have Java, we have JavaScript. But that's not all, because in SQLcl there's a bunch of other things, like we have Liquibase is part of it now for automating creating tables and other objects in the database. We can exit out and run a host command to do things. And there are also features to check our TNS names, and we can do TNS ping and so forth from within the tool. So it is really becoming a one-stop shop for automating things, because when you automate, you can't do it in SQL Developer. It just doesn't work right, because that's a graphical environment, and that's not how you automate things. But speaking about SQL Developer, one thing to mention here clearly is that all that we've talked about today, all these tools that you can build or scripts you can write and use in SQLcl, well, unless you do something very strange, they will just work just as well in SQL+. Not SQL+, in SQL Developer, sorry. So I think it is becoming a fantastic tool, and it's used way too little. I see people, and myself included sometimes, back to the muscle memory. It's so easy to just fire up SQL+, just because we're so used to it, or that you never leave SQL Developer because, again, you're very used to it, and it's not always that is the most convenient tool to use for what needs to be done. And there are no comments or questions that I see, so we can share this screen, I guess. But so with that, we'll wrap up this. Thank you for tuning in, and